Hey guys, welcome to day 3 of solving LeetCode daily challenges. So today's problem is find polygon with the largest perimeter. You are given with an array of positive integers nums of length n. So what is a polygon? A polygon is a closed plane figure that has at least 3 sides, and the longest side of a polygon is smaller than the sum of its other sides. Let's say there are 3 sides of a polygon. A, B, and C are given. A is the largest one, then A is less than or equals to the sum of B plus C. It can be equals to or it can't be. So next, conversely, if we have a K, that is K greater than or equals to 3, positive real numbers are given. Let's say A1, A2, A3 and so on till AK, where they are in ascending order and their sum is greater than AK. Then there always exists a polygon with K sides whose lengths are A1, A2, A3 and AK. We need to return the largest possible perimeter of a polygon whose sides can be formed from the nums. If there is no such possible polygon, then we need to return a -1. So what is a perimeter of a polygon? A perimeter of a polygon is the sum of length of its sides. Let's see an example where -1 case is true. Given that 5, 10, 5 and 50 are elements in the nums array. Let's say 5 plus 5, that is 10. It's less than the largest side, so we cannot find a polygon with such sides. And 5 plus 5, that is 10, is greater than the 5 or other side. Let's say here the max is 5 and sum of other two sides is 10, which is greater than the largest side. So we can find a polygon here and return the sum of the sides. Okay, so let's take an simple example. Okay, consider an array of 1, 5, 2, 7 and 10. Let's do this. So first approach will be a backward iteration. Let's say sum of this array will be 25. Okay, so first I will traverse in a backwards. So first I'll take 10 as current index, like I equals to 10, and let's say s minus I will become 15. Now let's compare this both. We can see that sum is greater than the 10. We'll update the sum equals to 25 itself or return this sum as the answer. So in this case, we'll just compare the element in the nums array in backward direction. We'll just take sum minus the current number. Check if the sum minus current number is greater than the current index number. If the condition is met, we'll return sum plus the current index number. If the condition is not met, we'll just return -1. So let's do the code part. Okay. So first I'll sort the elements because as it is given, it should be in ascending order. So we'll first sort the given elements and then traverse to back find the sum as s equals to sum of nums array, and we'll take for I in range of length of nums -1, as we are traversing in the backward direction, -1, and we'll just do sum minus equals to nums of current index. Let's check if sum is greater than the current index number. If it's true, we'll just return sum plus nums of current index, else will return -1. Let's check if the code runs fine. Yeah, it runs fine. Let's submit it and see if this approach is true for every possible case. Yeah, it is true. Okay. So let's see other condition, like optimal way of finding it in a greedy solution. Let's know why the greedy solution works in this problem. Suppose there are given a set of integers in the nums array like a1, a2 till ak. Now the sum of this can be like a1 plus a2 plus and so on plus a k minus 1 is less than or equals to ak. As you see that this is the largest side and the sum of all these sides is less than the particular side, then it can be like we cannot form any polygon with ak in that is k number of sides. It can also be possible that there might be a polygon existing with k minus 1 sides with ak included in it or ak minus 1 excluded. So there might be in this case like ak minus 1 and ak can be not included. Then there might be some cases like k minus 2 sided polygon can exist. So we need to find every possible case in this and find which sides are included in the polygon and which are not included. So let's see a simple example. Let's first take an array of 10, 5, 2, 7 and 30. First sort this given array. Sort it into like 2, 5, 7, 10 and 30. First we need to initialize sum as sum of for 0th index element and first index element. Let's say 2 plus 5 that is equals to 7 will be our first sum, and now we need to traverse from 2 to n minus 1. Here it is 0, 1, 2, 3 and 4. So 2 to 4 we need to traverse. First we'll take the second index element and compare it with sum. Like check if this sum is greater than the current index element. If it is greater, let's see 7 is greater than 7. No, it's not. That is, it's false, right? So we'll just increment the sum value to sum plus the current index element, that is equals to 14. Now let's say this 14 is greater than the third index element, that is greater than 10. Yes, it's met. So now we'll take a variable parameter. Firstly we initialize the parameter to parameter equals to 0, and now we'll just increment it to sum plus the current index. What is the current index? It's 10. So the parameter will be 24. Now we got our new parameter here, and let's move to the next index. Let's check and we'll increment the sum to 24, that is sum plus current index element. Okay, so now we'll compare if 24 is greater than 30. No, it's not greater than 30. So we'll just end the loop here and check for if parameter equals to 0, then we'll just return -1. Here the parameter is not 24, so we'll just return 24 as the parameter. Let's move to the code part. Let's as the nums is already sorted, we'll take s equals to nums of 0 plus nums of 1, and then for I in range of 2 comma length of nums, we'll check if the current sum is greater than the current index integer. If it's true, we'll just add parameter equals to sum plus nums of current index, And if it's not true or this condition is not met, it the below condition is always executed, that is sum will be incremented to nums of I, and we'll check if we'll return -1 if the parameter equals to 0, else we'll return the parameter. Let's check if this solution code runs. Let's just initialize it first equals to 0. Yeah, the code runs fine. Let's submit it. Yeah, the code is submitted successfully. Let's talk about the time complexities here. So the time complexity of sorting will be logarithmic of length of the array. So here the time complexity will be like order of log of n, and in this pass it will be order of n. Order of n. So the total time complexity of this code will be order of n log n, and the space complexity will be order of 1, as we are storing only parameter or sum as the variables. So that is it for today, guys. Thank you for watching.